So we are going to take a look at using the imaginary number I with conjugates. And we've used conjugates when we have done square roots. We've used it when we're solving equations. So now we're going to apply it to using it with imaginary number I. So let's say you had 2 plus 3i, and we wanted to find its conjugate. The way we would do that is we're going to change this middle sign to the opposite. Since right now it's positive, or a plus sign, what we're going to do is we're going to make it negative. So we're going to do 2 minus 3i. And so notice the only thing that changed is the sign. And that is how we're going to get a conjugate. And it's only the sign in the middle, to remind you. Okay, so, and one way that this can come up is when we are multiplying conjugates together, whether that's to simplify or solve an equation. So let's use the ones we have above. 2 plus 3i times 2 minus 3i. And we're going to FOIL it. So we're going to do the first values. And so 2 times 2 is 4. Our next value is O. So we're going to do outer. So 2 times negative 3i, so minus 6i. And then inner, so we're going to do 2 times positive 3i. And then we're going to do last. So last is right there. And so last is 3i times negative 3i. So we're going to have negative 9i squared, because we have 2 of them. And what that gets us is we have a 4 here. And then this negative 6i and positive 6i, they cancel out. So we can actually leave those alone because that actually adds to 0. And so what we end up with is just minus 9i squared. Now, if we take a look at what 9i squared or what I squared actually is, we can take a look over here. I squared is actually equal to negative 1. So we're going to plug that value also in. So we're going to do 4 minus 9 and replace I squared with a minus 1. So that's 4 minus 9, and then we have a minus 1, so that's positive, and 9 times 1, positive, 9. So 4 plus 9 is 13. So notice we took 2 conjugates that didn't really give us a single answer, and then we ended up with this really lovely answer at the end. And we're going to do that same thing, but for a division problem. And it's going to be really similar looking to one you've done before when you've simplified to factor. So let's do 2 over 1 plus 3i. Now, you're not given the conjugate this time, which means you have to actually figure it out yourself. So our value we're looking for, 1 plus 3i, its conjugate is going to be only changing the middle value. So 1 minus 3i. And that means we're also going to multiply it on top. 1 minus 3i. And so let's work our way through this. So on the top, for now, I'm just going to leave it like this. 1 minus 3i, we can simplify it later. And on the bottom, 1, we're going to FOIL it, right? So 1 times 1 is going to be 1. Our outer values, 1 times negative 3i is going to be minus 3i. Our inner values, 1 times 3i. And then our last, which is going to be 3i times negative 3i. So it's negative 9i squared. Similar to our last one, right? So we're going to do the same thing that we did before. We're going to take a look at simplifying the bottom. So negative 3i and positive 3i cancel out. So those are going to go to 0. So we have 2 times 1 minus 3i over 1 minus 9i squared. And we know I squared from before is negative 1. So we're going to do 2, 1 minus 3i over 1 minus 9 times negative 1. And then we're going to try to kind of fit this in. So we're going to put it right here. So 2 times 1 minus 3i over negative 9 times negative 1 is positive 9. So we're going to do 1 plus 9. So it's 2 over 1 minus 3i over 10. All right, now take a look at that 2 and 10. We can simplify that to 1 and 5. There we go. So our final answer is going to be 1 minus 3i on top, or in the numerator, over 5. And that's going to be our final answer for simplifying this problem.